Welcome to this video, which deals with a mathematical model where you have slope involved in the equation. The key phrase in knowing whether or not you have slope or not slope is when you see the phrase, as in this example, that says rate of, or rate of change, or rate of increase. Look at this problem with me. In 2007, the life expectancy for a female born in the United States was 80.97 years of age, so they lived a little past 80 years old. It was increasing at a rate of 0.3 years every year. Model this situation by a linear equation. Basically, in doing this one, use the equation of the form y equals mx plus b. The m, of course, as always, is going to be your slope. The b you can think of as this starting value, or the intercept. Even though we say it as the y-intercept, you can think of it as the starting value right here. Basically what it's saying is the 0.3 years that I mentioned a minute ago is going to be the slope. That's going to go right there. The 80.97 years, which is the basis for the initial life expectancy, is going to go right here. So when you write the equation out, it's going to be y equals 0.3 times x plus 80.97. So your model will be this model right here. Now again, this is based on the fact, and you have to be understanding how this works right here. If x is equal to 0, y will be 80.97. So you basically have to associate the 0 value, or the base value, with the year 2007. And that's the key to handling this kind of mathematical model. So if x is plugged in as a 1, we're talking about 1 year later, which is 2008. If x is 2, we're talking about the year 2009. You don't want to actually plug 2007 and 2008 physically in here where x is, because you'll get a very crazy number. You'll have people living to about longer than biblical people, thousands of years old. So when the equation, the second part, says to use the equation to estimate the life expectancy of a female born in the U.S. in 2020, what you have to do is take this 2020 and pair it up the way I did right here with the 2007. 2007 is represented by the number 0, 2008 by the number 1, etc. And you can tally this up to find out what value is associated with 2020. And you can do that much more easily by subtracting 2007 from 2020. If you do that, you end up with the number 13. Again, 0 goes with 2007, 1 goes with 2008, 2 goes with 2009, 3 goes with 2010. If you did it that way, you'd end up with the number 13 going with 2020. So what I would do is I would take this mathematical model right here, y equals 0.3 times x plus 80.97, and I would take the 13 and I would substitute the 13 right here in the place of x. So you'll end up with 0.3 times 13 plus 80.97. And again, you can do this on a calculator. And if you did this on a calculator, you would have this part right here would be 3.9 if you did the math. That's 0.3 times 13. And if I do this over here to the side, I get 3.9 plus 80.97, and that will be equal to the expected age. So if I take 80.97 and add 3.9 to that, keeping the decimal straight, I would end up with 84.87. So in summary, in the year 2020 or 2020, the age expectancy would be 84.87 years for that female to live. Hopefully this helps you with this problem, and again, as always, get tutoring, help from another student, or contact me as instructor if you have additional questions. Welcome to this video that will deal with finding equations of lines when you're given the slope and possibly a point for the line, the point that is on the line. In this situation, I have the slope formula that I'm going to box right here in black. You subtract the y coordinates and subtract the x coordinates. We'll have to deal with this in just a few minutes, but right now in situation number 1 we have a setup where a point on the line is -6, -1, and the slope is equal to -5. And when you're given the slope already, all you have to do is basically plug the information into the formula. So I'm going to do this right here so you can see it. I'm going to put the -5 right there. And for the x and y values, you have to be careful. The x value is -6, so I'm going to put the -6 right there. And I'll put the y value -1 right here. Now notice how that reads. Y minus -1 equals -5 parentheses x minus -6. I've isolated this right here one more time so that you can see what happens. -5 will go right there. The y value -1 will go here. The x value -6 will go right there. So again, the -5 is the slope, the -1 is the y value, the -6 is the x value. Now we only substitute where the subscripts are. We never substitute for the value of y itself. So what happens when I finish this is I've got y minus -1 equals -5 parentheses x minus -6. I basically have just brought this stuff straight down here where you can see what I've written down. Then once you have this set up, you want to solve the equation for y. These two minuses will become y plus 1 equals -5 parentheses x. The two minuses become a plus, x plus 6. I'm rewriting the y plus 1 side and I'm multiplying the -5 times the x and the positive 6. So I get -5x, 5 times 6, negative times positive is -30. To solve for y, I simply subtract 1 from both sides and I end up with y equals -5x minus 31. And that's the way you do an equation of a line whenever you have a point and slope. You basically just plug the information into the formula, only substitute for the subscripts x1 and y1, not for the y and x, and once you've done this, you simply solve it for y and your equation is done. Hopefully this helps out for situation 1. In the next situation, you have 2 points given to you. I have an example here where the points are 2, -6 and -1, 4. Again, remember from a previous video that if I wanted to plot these points or just sketch them briefly on the XY coordinate system, I could go over 2 and down 6 to get 2, -6. I could go over -1 and up 4 to plot that point. When I connect these dots, I notice that the slope leans to the left, so I should have a negative slope for my answer. Now I'm going to erase that for right now, and we'll actually get the slope, because for the point slope formula, we have to have the slope no matter what we're doing. Now I don't have the slope staring me in the face right here, so I have to use this formula right here in order to calculate the slope. So I'm going to do that. Now I'll get this out of the way so we can look at it. Alright, I have to decide which of the points is x2, y2 and which of the points is x1, y1. It really doesn't matter. It's up to you. I'm going to let this one be x1, y1 and this bottom one be x2, y2. Again, I have to be consistent. So when I fill these in the little point slope formula, in the slope formula, I'm going to fill them in like so. The x1 is going to be 2. So I'm going to put the x1 right here where 2 is. 2's right there. The y1 is negative 6. That's going to go right there. The x2 is negative 1. That's going to go right there. The y2 is equal to 4. That's going to go right there. So if I'm looking at this again in a little better situation, y2 is equal to 4. y1 is negative 6. I've got a subtract symbol between them. x2, x sub 2, the second x, is negative 1. And the first x is plain old 2. Rewind this if it's confusing you. And just do the math right here. 4 subtract negative 6 is going to be 4 plus 6, which will be 10. And minus 1 minus 2 is going to be minus 3. So I've got kind of a funky number right here. The slope is equal to 10 divided by negative 3. Now I can write the negative out front if I want to. So the slope is equal to negative 10 thirds. Alright, I now have the slope, which I can place right there. Now as far as this other part where I've got the y1 and the x1, you can actually pick either one of these you want to. Since I've got y1, x1 selected right here, I'll choose these guys. So when I plug these in, I'm going to have, I'll write this down over here so you can see it a little bit better, a little bit less cluttered. We only substitute where the subscripts are. So m, the slope, is minus 10 thirds. Y minus, the y1 value is negative 6. So I'm going to take that negative 6 and put that right there. That's the y value. So I'm going to put in negative 6 right here. The x1 value is 2, so I'm going to put that one, put that one right there. So I'm going to have parentheses x minus, and that's plain old 2, isn't it? Alright, now I forgot the equal mark. I need to put that right there. So I'm going to actually move this down where it will be a little bit easier to see. Now write that as y, the 2 minuses become plus 6, equals negative 10 thirds, parentheses, x minus 2. And again, now what we do, as always, the convention is to solve for y. So we rewrite the y plus 6, and I just multiply these guys. I just distribute the 10 thirds in both places, so I have negative 10 thirds x. And when I multiply this part, negative times negative is a positive. 10 times 2 is 20 over 3. I solve for y by subtracting 6 from both sides. And I'll do that in a different color so you can see what I did. And when I finish this up, I'm going to have y on one side by itself equals negative 10 thirds x. And to add the 20 thirds, subtract 6, I have to get a common denominator. 6 is equal to 18 thirds. I'm just doing that fast for you. That's math 60, and that's going to be 2 thirds right there. So your final equation is going to look like this. Y is equal to negative 10 thirds x plus 2 thirds. Hopefully this helps you out. Just replay and replay the video as necessary. If you have questions, get some tutoring, find a student that will help you, or ask me through email or in class.